In this video, we'll look at whether HBr, this is hydrobromic acid, is ionic or covalent. The short answer is it's covalent, but it's polar covalent. So let's take a look at what that means. So when we look at HBr and we find hydrogen here, that is a nonmetal, and Br, bromine right here, another nonmetal. When we have a nonmetal and a nonmetal bonded together, we're thinking that it's going to be a covalent compound. So according to our periodic table here, two nonmetals, HBr should be a covalent compound. Let's take a look at the difference in electronegativity between the hydrogen and the bromine atom. So here's the periodic table arranged with the electronegativity written, and we find hydrogen right here, which is 2.1, and then bromine 2.8. So the difference, 2.8 minus 2.1, that's only a difference of 0.7. So that's the difference in electronegativity between the hydrogen and the bromine. When we think about whether a compound's ionic or covalent, it's more of a continuum from ionic to covalent. And then in between, we have polar covalent. So with a difference of 0.7, that means that HBr is going to be a polar covalent compound, and that the electrons that are shared between the hydrogen and the bromine, they're going to be shared unequally, more towards the bromine. So based on the periodic table and based on the difference in electronegativity, we consider HBr, hydrobromic acid, to be a covalent compound, a polar covalent compound. When you put HBr in water, it will dissociate into its ions. It's a strong acid. So even though it dissociates into its ions when you put it in water, we consider it polar covalent based on our definition here and based on the periodic table having a nonmetal plus a nonmetal. This is Dr. B, and thanks for watching.